So in this next lesson, what you're going to be learning about is how to use trigonometry to solve worded problems. So in this, you might be asked to find unknown side lengths, heights, things like that, but you might also be asked to try and find angles as well. So we need to be able to decide what it is we're looking for or what we need to find. In this lesson, you're going to be using your knowledge of trigonometry to solve worded problems. So we need to be able to select key information from the question, so you can highlight or underline or however you like to do it. Then you need to draw a labeled diagram. Some questions will actually ask you to provide a diagram, but I think it's always good to draw one just so you can be confident of what you're actually looking for. Then you need to be able to select a strategy. So that means, are you finding an angle or a side, or what are the multiple steps that you need to take to try and get to your answer? And then that's when you have to choose the right ratios, so sine, cosine, or tan, substitute values in, and then solve to get your answer, whether that be an angle or a side length of your triangle. For our first example, we've got Julia. So Julia went hiking. She travelled north 80 degrees east for 6 kilometres. How far east did she walk? How far north did she walk? So the way that question is worded, if we think about a compass, we've got a compass here, we've got north, east, south, and west. So if we're traveling 80 degrees north, 80 degrees east, what we're really doing is we're 80 degrees from north, but heading towards east. Okay, so that's what that means. So if I was to draw a triangle, because it's trigonometry, so there's going to be a triangle, spoiler, you're going to find that if this is where Julia started, so this is the start point, she travelled 80 degrees, so 80 degrees is going to go here, because this is north and this is east. Okay, so north to east, it's 80 degrees from that way. Okay, that's what that's saying. So she's travelled in this direction. So this is the part where she's walked. So this, she actually hasn't walked here. So this is like a dotted line almost. Okay, so Julia's actually walked this part. So Julia has walked 6 kilometres from the start. She's gone this direction. Okay, and we can tell that it's that direction because it's north to east 80 degrees. So it's gone 80 degrees and she's walked that way. Okay, so what we need to find is we need to find how far north she walked, because north is this way, and how far east she's walked, okay, from the starting point. So let's do east first, because that's what the question's asking us. So we need to label the sides of our triangle according to this angle here. So obviously we'd have a right angle here. So that makes this the hypotenuse. According to this, we've got a side that's far and a side that's close. So this is going to be our opposite and this is going to be our adjacent. Okay. So we use so, car, toa. So if I'm thinking about this side that I'm trying to find, I don't need this one, okay? I want the one that has a value and one value that I don't know, okay? Because if I try and use that one, I don't know either of them, so that doesn't really help me. So I need to use one that I do know and one that I don't know. So an O and an H is what I've got here, okay? So to start with, for part A, I'm going to use sine of an angle is opposite over hypotenuse. So the angle that I'm using is 80 degrees. So I'm going to now substitute. That's 80 degrees. O is going to get changed to an E because that's what I've decided to call it. And then H is going to get changed to a 6. Okay. So I'm trying to find east. I need to rearrange now. So it's going to become 6 times sine of 80 degrees. Now remember, I'm trying to find a side length here, so I'm not using an inverse. Okay, I need to use the standard form of that because I've moved that whole thing across. Now I need to use my calculator, so I'm going to go 6 times sine of 80. And that's going to give me 5.91 kilometers is what this question is in. Okay, so that's my answer to part A. Now I need to do part B. Now I'm trying to find this side now. How far north did she walk? Okay, so I need to decide what ratio I need to use. So I'm not using this top one, okay? I'm using the H and the A. So if I'm using an H and an A, that means I'm using this one. Okay, so we're going to use cos A over H. Now I need to substitute cos of, it's going to be 80 degrees again because we're using the same angle. A is going to get changed to N for north, and H is going to get changed to 6. So I'm trying to find north. It's going to be 6 times cos of 80 degrees. I'm rearranging. Then I need to use my calculator. I'm going to type in 6 times cos 80, close my bracket, and I get 1.04 kilometers is how long that side is, or how far north she traveled. Okay, so in order to solve this question, I had to interpret the question and select key information. I drew a labeled diagram, then I chose which trigonometric ratio I needed to use. I substituted, rearranged where necessary, and then found my answers. For this next one, we've got a tile in the shape of a parallelogram that has a diagonal length of 50 millimeters and an obtuse angle of 120 degrees. We need to find the height of the tile. So selecting our key information, we know that it's a parallelogram. We know the diagonal is 50 millimeters long and that there's an angle of 120 degrees. So the next step after we found our key information is to draw a label diagram. So I'm going to draw a parallelogram here as best I can. Okay, now you can already see which length is going to be the diagonal. So the diagonal is going to be this length, 50 millimeters, which these are going to be the same. Okay, then it's also saying that we've got an obtuse angle of 120 degrees. So you can tell these are acute because they're small. This is going to be obtuse. So this is 120 degrees, okay, which makes this the same, also 120 degrees. We need to find the height of the tile. So the height of the tile is going to be going directly up and down. This is going to be the height of my tile. All right, so what we need to do now is we need to try and make a triangle somewhere in here. Now, if I make my triangle start here, it's actually going to cut this angle, but I don't know how much it's going to cut my angle. So what I need to do is I would be trying to find what this angle is here. Okay, that's the strategy I'm going to use. If you can think of a different strategy, that's great, but I'm going to use that strategy. So what I know about quadrilaterals, so any four-sided shape, they add up to 360 degrees, all of their angles. So I'm going to use my knowledge of quadrilaterals to try and find out what those two angles are. So in order to do that, this, as I said, is already going to be 120 degrees. So I'm going to have 360 take away 240, and I got 240 by adding these together. That'll give me what's left over here, okay? So that's going to give me 120 degrees left over. So combined, these need to add to 120 degrees. So I'm going to halve that, and I'm going to get 60 degrees. So I've been able to determine that this angle here is 60 degrees, okay? So what I've actually got is I've made myself a triangle here. This is the height I'm trying to find. This angle here is 60 degrees. It's beautiful, 60 degrees. And I know that this is 50 millimeters. So I'm going to use my knowledge of this angle, this side, to try and find this side. Now it's probably a little bit confusing that I've called that H, but this is my hypotenuse. This side's far away, this side's close, so that makes this my opposite. So now I need to try and decide which trigonometric ratio I'm going to use. So I know that my trigonometric ratios are SO, CA, TOA. I need an O and an H. So an O and an H is sine. So I'm going to write sine of an angle, which I already know is opposite over hypotenuse. Now I'm going to substitute sine of 60 is going to be H, that's my height, over 50, because that's my hypotenuse. So my height is going to be 50 times sine of 60. I'm going to do that on my calculator. So I'm going to go 50 times sine 60, close bracket, and that's going to give me 43.3 millimeters. I'm going to round that to 43 because that's the question, is in that same format with no decimal places. So again, what we did was we selected our key information, we drew a labeled diagram, came up with a strategy, chose the right ratio, substituted, rearranged and solved and rounded if we needed to find our solution. For this third example, we've been given a flagpole that is 6 meters tall. The cord used to support the pole is 7 meters long. What angle will the cord make with the ground? So again, selecting key information. So we've got a flagpole that's 6 meters tall. We've got a cord that's 7 meters long. Okay, so I should specify that the flagpole is 6 meters. The cord is 7 meters long, and we need to find the angle that the cord makes with the ground. That's very important, so we know which angle we're trying to find. So I'm going to draw a flagpole here, and I'm going to draw its cord, and I'm going to draw the ground. Okay, so if this is the flagpole here, you can see this is our beautiful flag blowing in the wind. This is 6 meters tall. This is going to be the cord that's used to support it. So that's 7 meters. And if we're trying to find the angle the cord makes with the ground, this is the cord, this is the ground. So that means we're trying to find this angle here. Now we need to label our sides. So this is a right angle. If I turn that into an arrow, that makes this my hypotenuse. I've got a side that's far and a side that's near. So the side that's far is this one, so that's going to be my opposite. I'm going to write out SO, CA, TOA. I'm going to look at my ratios. I need an O and I need an H. So an O and an H is going to be sine. So I need sine of an angle is opposite over hypotenuse. Now it's time to substitute sine of an angle because we don't know what this angle is yet. The opposite is 6. The hypotenuse is 7. So now when we rearrange, I want my angle on its own. So if I want to move just that sine over, we need to use the inverse of sine. So sine -1, 6 over 7. Okay, now I need my calculator to do this part. If this is confusing for you, you need to go back and watch our last video about finding angles in using trigonometry, okay? So then I'm going to do the inverse of sine. 6 divided by 7, that's how I write it. 6 over 7 is 6 divided by 7. And that is going to be 58 0.997, and if I'm rounding to the nearest degree, which is generally what we do, it's going to be 59 degrees. So that is the answer for this question, 59 degrees. So we chose key information, we drew a label diagram, we used our sides to decide which ratio we need, and then we rearranged and used an inverse because we were trying to find an angle. For this last one, we've got council regulations state ramps should not have an incline greater than 3 degrees. If a school is building a ramp that has a vertical measurement of 1.2 metres and a horizontal of 20 metres, will it meet regulations? So the incline cannot be greater than, should not be greater than 3 degrees. So the school's ramp is vertical 1.2 metres and horizontal 20 metres. So now I need to draw a picture. So it's going to look something like this. Like it's going to be really long and not very high because this measurement here, the vertical, is 1.2 metres and the horizontal, we are told, is 20 metres. Oh, that looks terrible. The horizontal is 20 metres, okay? So what we need to find is whether the incline is 3 degrees or under, it's okay. If it's anything over 3 degrees, like even if 0.00001, then it's too much, okay? So of the remaining angles, this angle here is our incline, okay? Because that's how much the ramp rises by, okay? That's the going up bit and the going down bit, okay? So this bit is the bit we're trying to find, all right? So I need to label according to this angle, okay? So this is my hypotenuse. The close side is this one, this is adjacent, and this side is my opposite. So this side here isn't important to me. I need to think about SOHCAHTOA. I've got an O and an A, which means I'm going to use TOA. Okay, I'm going to do this up here. So I've got tan of an angle is opposite over adjacent. I need to substitute my values. Okay, I need to substitute my values. So tan of an angle, I don't know what this angle is. O is going to become 1.2 and A is going to become 20. So if I'm trying to find the angle, that means I need the angle on its own and I need to do the inverse of tan. So that's going to give me 1.2 over 20, the inverse of tan. I need to use my calculator here. So I'm going to do the inverse of tan, 1.2 divided by 20, close bracket. We get 3.4, 3.43, and so on, okay? So what we can say here is that this is greater than 3 degrees. So will it meet regulations? No, because it is greater than 3 degrees. Okay, so that is the answer to our question. So if we think back to our learning intention and success criteria, the learning intention was to be able to use trigonometry to solve worded problems. We had to select key information. We had to draw a labeled diagram. We had to choose the right ratio. Then we had to substitute, rearrange if need be, and then solve to find our answer. So if you can do all of those things, then you've met today's success criteria.